the ACAH, which is a completely different peptide, is very, very good against certain gram-positive bacteria. And I haven't put the whole list up here because there's just not enough space on the slide. So we are discouraged, very discouraged, because we don't have a uniform response against all bacteria of the same group. We're very, very encouraged because of other experiments we have going on. Encouraged because we can actually do this process. So right now, we're using some computer software to actually help design and infer killing motifs and binding motifs. And we have a whole series of peptide arrays that we'll be assessing in terms of binding to bacteria and then developing those as the basis for some of our HAMP work. We can alter the target and specificity and the MIC of certain of our antimicrobial peptides. We can mix the binding motifs and the killing motifs. We have 2 I've shown here. We have 3 others which we have assessed, and we are designing and making new ones. The idea is that we can test newly designed and binding motifs alone. So we take a binding motif alone and make sure it really does bind strongly to its target. And then with killing motifs, putative because they haven't been proven yet, to compare with the parent molecules from which we took those molecules, and a stepwise but very time-consuming laborious process, ultimately come up with a new binding motif that we can then combine with different lethal motifs to actually create new antibiotics. They have to be toxic to the microbes we want to kill. It doesn't do much good if you have an infection and I can kill the microbe in you, but as a secondary effect, you also die. There are, I believe, 3 other studies